In question 9, it says relative to the origin, the point A has position vector as given. The line L has the equation. We have to find the position vector of the foot of the perpendicular from A to line L. Hence, find the position vector of the reflection of A in line L. So first of all, we have to find the position vector of the foot of the perpendicular. So let's say this is A, and let's say this is line L over here. So this will be the foot of the perpendicular over here. We can say this point is X, and we have to find this coordinate. Now, and this will be perpendicular. Now, what we know is that if two lines are perpendicular to each other, we know that their product, the scalar product is equals to 0. The formula that we use is A dot B is equals to A B cos theta to find the angle. And if the angle is 90, cos 90 is 0. So A dot B is equals to 0. But for that, we'll need the direction vectors of both of these lines. Now, for the line over here, we already have the direction vector, which is 3i minus j plus 2k. But we do not know the direction vector for the line AX. What we will do and what we have to do in every single question like this is, first of all, what we know is that X lies on the line. So if X lies on this line, the equation of the line is 9 minus 1 and 8 plus mu into 3 minus 1 and 2. We can write it as 9 plus 3 mu minus 1 minus mu and 8 plus 2 mu. Now, every single point on this line will have this coordinate, but with a different value of mu. For x, we don't know the mu value, but we can just take our coordinate of x as, so the OX coordinate will be 9 plus 3 mu minus 1 minus mu and 8 plus 2 mu. So if we have to find the direction vector of AX, we know that AX is x minus A. So x minus A will become, this will be 9 plus 3 mu minus 1 minus mu and 8 plus 2 mu, and minus the coordinates of A are 1, 2 and 4. 1, 2 and 4. So 9 minus 1 is 8. That becomes 8 plus 3 mu. Minus 1 minus 2 is minus 3. And 8 minus 4 is 4 plus 8 mu. So now we have the direction vector of AX, which is in terms of mu. So we'll now substitute this into this formula A dot B. We already have the direction of the line, which is 3 minus 1 and 2. So 3 minus 1 and 2. And when we multiply it with the direction vector of AX, that is 8 plus 3 mu minus 3 minus mu and 4 plus 8 mu. And that will be is equals to 0. So when we expand it and multiply first, that will become 8 is a 24 plus 9 mu. And then minus 3 into minus 1 is plus 3 plus mu. And then plus 8 plus 16 mu. Finding the value of mu, 9 plus 1 is 10. And then 10 plus 16 is 26 mu. And we'll take this on the right hand side, 9, 8 and 3. So that will become 24 plus 3, 27 plus 8, which is 35. The value of mu is minus 35 over 26. Okay, so there is a problem with mu. All right, fine. We have the problem over here. This is 8 minus 4 is 4. So this should have been 4 plus 2 mu. So this becomes 4 plus 2 mu. And this will also be 2 mu over here. So this will also become 2. So we'll have 9 plus 2 to the 4. So this will be is equals to 4 over here. So 9 plus 1, 10, 10 plus 1, that will become 14. And then 35 divided by 14 will become, so this is minus 35 upon 14, that is equals to minus 5 upon 2. Now to find the value of x, we can now substitute this value in the direction of OX. So OX will be is equals to 9 plus 3 times minus 5 upon 2 and then -1 minus 5 upon 2 and 8 plus 2 into -5 upon 2. So this will become 9 minus 15 upon 2. So 9 to the 18. So that will become 18 minus 15 upon 2, which is 3 upon 2. So what we have now, these will be the coordinates of OX. -1 plus 5 upon 2, that will become -2 plus 5 is 3. So that will become 3 upon 2. And 8, this -5 will become 3. So the coordinates of OX, we can write it as 3 upon 2i plus 3 upon 2j plus 3k. Now in the next part, it says you also have to find the position vector of the reflection of A in the line L. So the reflection of A will be exactly over here. We can write it as A dash. Now what we know is that this A dash, X will be the midpoint of A and A dash. And we already have the coordinates of X. So the midpoint coordinates are, we don't have enough space. So the midpoint coordinates are 3 upon 2. The X coordinate, the Y coordinate is also 3 upon 2 and the Z coordinate is 3. Now to find the midpoint, we can write this as X, Y and Z over here. And A coordinates are 1, 2 and 4. 1, 2 and 4. So 1 plus X upon 2. So this will become 1 plus X upon 2, comma, this will become 2 plus Y upon 2. And we're just simply using the midpoint formula, and 4 plus Z upon 2. Now solving each of these equations, this is X, Y and Z. So 3 upon 2 is equals to 1 plus X upon 2. 2 and 2 cancel. So X will be is equals to 2. Then over here we have 3 upon 2 is equals to 2 plus Y upon 2. So that when we cancel this out, 2 and 2 will cancel. 3 minus 2 will be 1. So Y will be is equals to 1. And 3 is equals to 4 plus Z upon 2. So this will become 3 to the 6. 6 minus 4 is 2. So the value of Z will be 2. So the coordinate of the point of reflection of A will be, we can write it as 2i in vector form. That will become 2i plus j plus 2k.